Here's my 486 computer. I finally got all the memory issues worked out so I can use that 512 kilobyte static RAM chip without problems. I'm using a VT82C42N PS2 controller. So now that I've written a keyboard driver, I can use the keyboard. As you can see, the backspace button works, and I can type stuff in as well. It took me a while to fix that last memory issue. The problem was that in rare and specific situations, writing to a byte in memory and then reading from a different byte would corrupt a different byte in memory. This bug was incredibly difficult to track down because it only happens about 0.0042% of the time. I think what caused this is that sometimes when the SRAM enable signal and the memory write signal change at the same time, right before a memory read cycle, the amount of time it takes for those signals to change, which is only a few nanoseconds, is enough to make the static RAM chip write garbage to the RAM. The way I solved this is I got the FPGA to deassert the SRAM enable signal right before the end of a memory write cycle, and that seems to have fixed the problem. I'm not sure if I'll end up getting my V9958 video card to work with this or not. It doesn't have a bus transceiver on it, and it seems to cause bus interference whenever it's plugged into an expansion slot, even if the video card isn't being selected by the host system. The address decoding logic is working correctly, so the problem just has to be somewhere else. I might still be able to find a way to use FPGA magic to get it working anyway, but if I do have to make a different video card to get this working, it's not going to be based on a Yamaha V9958 anymore. This video card is really pretty annoying to deal with. The VGA port doesn't work because it doesn't output a standard refresh frequency. So I have to use the S-Video to see what's on there. So that means I have to run it through 3 separate adapters to record the video output, and that's just really annoying. So I want to make a video card that can output resolutions of 640 by 480 and hopefully also 1024 by 768. You need a 65 megahertz pixel clock to output 1024 by 768 video mode, which is probably pushing it a little bit, but it's definitely worth a try. The H-Sync and V-Sync signal doesn't seem very hard to implement on an FPGA, so I'm sure the hard part is going to be getting the FPGA to read pixels from VRAM while still allowing the host system to read and write to VRAM at the same time. I'm planning on using a combination of FIFO buffers and wait states to accomplish this. Hopefully I'll be able to have the FPGA copy from VRAM faster than the pixel clock needs to read from VRAM, and that'll just make that easier. I also might try to put an ATmega or some type of simple microcontroller on there. If this works, I'm planning on using it for Bressingham's line algorithm. Bressingham's line algorithm can be kind of a hard one to program in assembly, so it would be convenient if I could get a hardware-assisted method of doing this. If that actually works, it'll lay the groundwork for more advanced types of video hardware acceleration in future projects. This is what the video card might look like once I'm done with it. In the middle you got the FPGA, here's the SPI ROM, where the FPGA gets its code from. Here's some address latches. I don't know if I'm going to use address latches or address transceivers. I'm going to experiment with some motherboards that have ISA slots and figure out what I need to do. Over here is the data transceivers and stuff. This is the digital to analog conversion circuit. I bet that's going to change. I'm probably going to do something else. But yeah, that's kind of what it's going to look like. It's got the 16-bit ISA ports on it. So yeah, hopefully that'll work out. So that's all I have for today. If you would like to help support future development, consider buying me a coffee. The link is in the description. Thanks for watching. Bye.